Hello guys, welcome back to the Math Club. Wherever you are joining me from, this is Paul Ayok, your mathematics instructor. So the video I'm making today is a follow-up of my last video, which I posted on all my social media handles. It has to do with the Indian High School Mathematics of 2024, which was sent to me by one of my subscribers on YouTube. So this is the second part of the question. So let's get to it directly. Now, we are given this radical that the root of 1 minus x squared plus the root of 1 minus y squared equals a into x minus y. A is obviously a constant. And we are asked to prove that dy dx equal to the root of 1 minus y squared divided by 1 minus x squared. So the first derivative, which is dy dx, should be equal to this. Now, if you look at the equation very well, you discover that the temptation that most students will want to fall into will be to square both sides. Squaring both sides is going to lead you to a complex situation of radicals, which will be too long to handle. But when you observe thinly, you discover that there is a pattern within these radicals and this, which means if we can look for something to replace as x, so that when we square it and we take 1 minus the square of that particular term, and we take the square root, we do away with this one. We replace the term also with y, the variable with y, so that we'll take 1 minus that square, and we take the square root. Is going to also eliminate this root. That is how you answer this kind of questions. Because if you say you should square both sides, it's going to be too complex. And what is the ideal replacement for x and y in this radical? It will be a trigonometric ratio. So we are going to take a trigonometric ratio. So I'll say let x equal to something like cos A. You can also say let x equal to cos B, sine A. Pardon. You can say let x equal to sine A. There's no problem. So from here, A will be equal to cos. We go this way, it becomes cos inverse of x. So A will be cos inverse of x, which you can call equation 1. Then I'll also say let y be equal to cos B, so that my B becomes equal to cos inverse of y, which I can call equation 2. So therefore, this entire equation becomes the root of 1 minus, I replace x with cos A, so it becomes cos squared A, because there's a square on x, plus the root of 1 minus, I replace y with cos B, so that become cos squared B. All that should be equal to so A bracket x, which is cos A, minus y, which is cos B. So that now I have 1 minus cos squared A is sine squared A. And when we take the square root of sine squared A is sine A, plus 1 minus cos squared B is sine squared B. The root of sine squared B is sine B. All this should be equal to A into cos A minus cos B. Now, when you look at the left-hand side of this equation very well, we can apply the factor formula identity of trigonometry, sine A plus sine B. And we can also do the same here, so that I'm going to have the identity for sine A plus sine B is 2 sine A plus B on 2 cos A minus B on 2 should be equal to A. I put it inside a brace. Cos A minus cos B is negative 2 sine A plus B on 2 sine A minus B on 2. So that is the factor formula identity of cos A minus cos B. Now if you look at 2 can cancel here, so that now I have sine A plus B. If you even look at it right from here, we can also see that Sine A plus B on 2 and sine A plus B on 2 can cancel here and cancel here. So that we are left now with cos A minus B on 2 equal to A multiplied by this negative in my bracket is negative A sine A minus B on 2. So I will bring sine A minus B on 2 this way so that I can have cos A minus B on 2, all that divided by sine A minus B on 2, all that should be equal to negative A. Now, the cosine of an angle divided by the sine of that same angle is the cot of that angle. So that I will have cot. So this implies cot A minus B on 2 should be equal to negative A. So when I take cot this way, it becomes cot inverse. So I will have A minus B on 2 should be equal to cot inverse of negative A. Multiplying both sides by 2, I will have A minus B should be equal to 2 cot inverse of negative A. So replacing my A with cos inverse of X, I will have cos inverse of X minus replacing my B with cos inverse of Y using equation 2. So I have cos inverse of Y. All that should be equal to 2 cot inverse of negative A. Now I'm going to differentiate the left hand side. This is the left hand side. Remember, we call this my equal sign. I'm going to differentiate here, differentiate here, differentiate here. I'm going to differentiate term by term. Differentiate this term, differentiate this term, differentiate this term. So let's go. The differential of cos inverse of X is actually negative 1 divided by the root of 1 minus X squared minus the differential of cos inverse of Y is negative 1 divided by the root of 1 minus Y squared. Now, because this variable is Y and is not X, and we are differentiating with respect to X, I must multiply dy on dx behind. If you can refer to my last video, I made that explanation that whenever you are differentiating with respect to X and the variable is Y, after differentiating normally, you have to multiply that differential by dy dx. Since we are differentiating, if we are differentiating with respect to X, we don't multiply by dy dx. But when you are differentiating Y, you must multiply by dy dx. Now, the right hand side of the equation is a constant. There is no X or Y here. It's a constant. The differential of this constant on the right hand side is 0. So from there, I will make dy. Look at this sign, it's negative, and this negative will give us positive. So I now have 1 all over the root of 1 minus y squared dy on dx should be equal to, I take this guy the other way, this term, I take it the other way, becomes 1 all over the root of 1 minus x squared, because it was negative 1 here. It was negative 1 over here. So when it goes to the right hand side, it becomes a positive. So from here, I can get dy dx. This implies my dy on dx should be equal to 1 all over the root of 1 minus x squared divided by 1 on the root of 1 minus y squared, which I can say my dy on dx is equal to, when I invert, I'm going to have 1 on the root of 1 minus x squared times the root of 1 minus y squared all on 1. Now, this relationship that I have here is the same as this, because 1 multiplied by the root of 1 minus y squared will give you the numerator, and the denominator is the root of 1 minus x squared. Since this numerator has a root, the denominator also has a root. Because there is no space here, you can write it as the root all that on 1 minus y squared on 1 minus x squared. So if you don't know how to simplify this last part, you can send me a DM. I will respond to you. I'll show you how to arrive at this level, but it is already at this level because you have your numerator and you have your denominator. So ladies and gentlemen, wherever you are watching me from, like my videos, share, comment, so that you can encourage this page. See you next.